Kines 310. Don't adjust your phones or computer screens. It is I, Dr. Campbell. No shave November, October, November. I forget. But I am here today to touch base. I know you haven't seen my pretty face in a while. So I kind of wanted to prep you guys on the next lecture, do a little micro lecture, short, sweet, to the point. Try to wrap up the content that we've had so far in a nice, pretty kinesiology bow, and make sure you're on the right path for the information that's coming up next, okay? So, point number one, do not stop reviewing your motions. Muscles, the part that we're on, influence motion. I'm going to get into more detail specifics, but the point is that we don't just forget about flexion, extension, pronation, supination, extension, flexion, abduction. We have to still use those in our everyday lexicon, just life language, as you will. So you need to use these terms in your life language. If you're driving, when you take a right-hand turn, think about what your radial ulnar joints are doing. When you're stepping on the gas, taking your foot off the gas, when you walk into class, just practice these things in your head. It's like I've said several times to students that have asked for help, this is a new language, and the best way to learn a new language is to speak the language. Okay, so we got to practice speaking the language. To summarize where we are now with muscles, go back to your commandments and your support materials. Muscles can only pull. Muscles influence motion through pull force. They don't push and pull. Muscles can't push. My hand can push, but my hand is not a muscle. Well, you have muscles in your hand. Yeah. Muscles pull on bone, and bone can then push. So when you think about your feet pushing on something, it's because muscles are pulling on it, and thus the shoe, the foot, the heel, the bones can push. Bones push because our muscles pull. That's another way to look at it, okay? So don't fall down the trap of saying, well, muscles can push. Look, when I'm doing a push up. They don't call it a push up because you're pulling, they call it a push up. But your hands are pushing because muscles are pulling. I get very animated when I talk about muscles pulling. So, muscles can only pull. That's super important. And we talked about how in earlier videos, again, this is just a little summary, then I'm going to hit up some major important stuff that you're going to need for the next video to make it more effective. Muscles are always pulling. Always. But what about if you rupture it? If you're at rest, your muscles are pulling. Notice I didn't say they're working, but they are pulling. There's tension, there's tone. If we could do a thought experiment and you were at rest and I snipped your bicep tendon, theoretically, not like the movie Saw, but I snipped your bicep tendon, your bicep wouldn't stay the same length. If I snipped your bicep tendon while you were sleeping, it would roll up like a ball into your shoulder. Why? Because there's tension there. There's always pull force. Even when you die, your muscles have pull force. Rigor mortis sets in. The muscles are always pulling. What I want to separate, though, is although muscles always pull, they do not always work. Whoa. Think of it like this. When you are sitting down, relaxing, watching TV or watching a movie, is your body having metabolism, doing things? You're burning energy, you're thermoregulating, you're doing things at baseline that you can maintain all day. You don't get tired of being at rest. But there's a certain level of energy that rest takes. Okay. I could sit here all day and not get tired. That's my resting metabolism. But if I were to go jog a mile or just jog, I can't do that all day. That's what we consider work, above rest. We don't look at that work as 0 to here. We look at it above what your body was doing at rest. That's your metabolic work. Me running the mile isn't if I'm dead to running the mile. It's what my body's doing at rest and what is it doing when I'm running. That's the work. Same thing for contraction. Contraction and work are synonyms in our world because contraction means trying to shorten above rest. Here is your muscle's resting level of trying to shorten. You could do that all day, and never get tired of trying to shorten at rest. That's not work, that's rest. That's not contraction, that's pull force at rest. Contraction is what you do above rest. A little bit of contraction, like I can hold my arm out and that's easy. How long can I hold my arm out, right? Eventually, I'm just going to get heavy because I'm doing more than what my abductors are used to doing at rest, and they can't maintain that forever. That's work. That's contraction. That's doing a job above rest. Okay? A carpenter has resting tone, resting metabolism, but when they go to work, they go above rest, doing things above rest. That makes sense? Now, I explained why contraction can be confusing. Contraction, confusing. See what I did there? Because contraction infers shortening. You know, you think about a business contracting or your heart contracting, right? But skeletal muscles are not cardiac muscle. It's a little different, right? What contraction means for our muscles is trying to shorten. And I know that's like, what? You got to think of it with an open mind. Trying to shorten. Because if you think about it, isometric contraction. If you don't think about it the way I'm trying to teach you to think about it, that should be a contraindication. Isometric doesn't move. Contraction shortens. Well, which one is it? Rabble, 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 rabble. If you think of contraction as shortening, then isometric shortening makes no sense. I am here to make it make sense in my own unique, crazy Delcom way. Contraction does not mean to shorten. Contraction means when a muscle is trying to shorten above rest, above resting tone. So therefore, now everything fits. Isometrics, no change in length while trying to shorten above resting tone. And it's doing a job. You know, think about in the construction. Hey, Mac, hold this rope and don't let that bucket fall, right? You're doing a job. You're preventing something from, hold the ladder. Don't let it fall. Don't let it move. You're doing a job isometrically. No change in motion, preventing it from moving while working above rest. You can't maybe put force on that ladder all day. You're going to get tired because you're doing above resting tone. My speech therapist says I hold my breath when I talk with passion. Breathe. So contraction means trying to shorten. Isometrics, no change in length while trying to shorten above resting tone. Concentric contraction, shortening while trying to shorten above resting tone. The muscle is doing what it is trying to do. You think about playing a tug of war. I am trying to shorten the distance between what I'm pulling on and myself. I'm trying above rest. I can't hold that rope all day. So think about the three possible outcomes. Isometric, I'm trying to shorten it, but it's not moving, and I'm working above rest. Concentric, shortening the distance between us while trying to shorten above resting tone. I'm doing what I'm trying to do. Concentric contraction is the ultimate victory. Positive possum thinks you can do the thing. The one that gets people flipped up is eccentrics. Being lengthened. Muscles can't lengthen themselves. Think about that for a second. Your muscles cannot lengthen themselves because they can only pull. Think about a rubber band, right? If I take a rubber band and I leave it on the table, that rubber band can't generate more pull force. Our muscles can because we have, little cilia, the filaments that can create pull force. But the point is, if I take the rubber band and stretch it, it can shorten itself, but it cannot lengthen itself. And it's the same thing for the little cilia. Because the cilia are trying to shorten, therefore they cannot lengthen themselves. You need other things to lengthen it, like gravity, other muscles, weight that you're working on, machines. Your muscles cannot lengthen themselves. So let's go back to our tug-of-war analogy. If I'm trying to shorten above rest, right, doing a job, trying to shorten the distance in my tug-of-war, but what if the distance starts to lengthen? Muscles are still pulling this way, 2 thumbs up. But yet the distance is lengthening. A muscle is being lengthened while trying to shorten above resting tone. That's eccentrics. So the cool thing here, and I'm trying to work my way to this board. The cool thing here is muscles themselves, we can't think of. Technically, is it true? Muscles influence motion? Technically, but that's being obtuse. We need to think of it more in depth. We don't say things like humans put out fires. That's true, but specific humans with specific functions put out fires. Firefighters put out fires. Yeah, they're humans, but they serve specific functions. We could say humans cure people of diseases. Incredibly oversimplified. Doctor humans, scientist humans. How do these humans work to cure diseases? How do these humans work to cook dishes? Chefs cook dishes, or people who know how to cook. In other words, cooking is the job that produces the dish. So that's what I'm trying to get to with this on the board, okay? It reads as a sentence. And the next lecture is going to be all about this concept. Because at the end of the day, guys, this is what it's about. Do muscles influence motion? Yeah. Just like humans put out fires. More specifically, more importantly, more in-depthly, muscle groups influence joint motions specifically through their contraction types, through their contractions. Muscle groups influence joint motions through contractions. I'm going to give you a very easy example of this. Okay? Doing curls. Let me see if I can get these keys actually weigh 85 pounds, so I'll make it look easy. Your instinct is like, oh, I'm working bicep. And I'm not saying you're wrong. I'm trying to teach you that bicep is one member of a group of muscles, right? The team, remember the team concept? And we name the teams by direction of pull of their force. How does the bicep pull? It pulls in a direction of elbow flexion. That's where it pulls. Even when you're sleeping, it pulls in the direction of elbow flexion. Even when you're dead, it pulls in the direction of elbow flexion. So what we don't say is, we don't say biceps function is elbow flexion. Why don't we say that? Because if I'm working isometrically, that bicep is doing a job, keeping my elbow in this same position, preventing gravity from extending my elbow. Come on, bicep, do your job. If it's working isometrically, do you see flexion? So its function isn't emotion. And I'm not saying like emotion, like, oh my God, I'm so emotional. Triggered. Its function is its direction of pull. And from that, it can influence motion through contractions. Concentrically, it can make the flexion happen when it's pulling in the direction of flexion. Eccentrically, it can let extension happen while pulling in the direction of flexion. Think about how an elevator works. Elevator can make it go up, prevent it from falling down, and let it go down, all the while pulling up. You don't have cables that pull down on the elevator. That'd be ridiculous. You'd go faster than what gravity can offer. The elevator is called an elevator, not because it brings you up. It's called an elevator because it also keeps you from falling down while pulling up and lets you go down at a nice, comfortable speed while still pulling up. An elevator is called an elevator because of the direction of pull of the cable. The cable pulls up, but yet it influences your motion both up and down while pulling up. It can make you go up, it can keep you up, and it can let you go down. Muscle groups and individual muscles who are in the groups influence joint motions through contraction. Again, you can't say, you can, but you're going to be fooled super duper easily. Bicep flexion, tricep extension. Check this out. Flexion, bicep. Extension, bicep. Flexion, bicep. Extension, bicep. I had the same muscle in the same group responsible for two different motions through, I'm not going to do it, contraction. The contraction was different. Think about it over your head. Tricep, right? Tricep. Well, I have flexion and extension. I have flexion and extension. So how can I have the same motions? Listen to me. I'm trying. How can I have the same motions, the same motion oscillations, flexions and extensions? How can I have the same motions with different muscles? Because of variations in contraction. Concentric, shortening while trying to shorten above resting tone. Isometric, no change while trying to shorten above resting tone. Eccentric, being lengthened while trying to shorten above resting tone. The bicep and the elbow flexors influenced motion, flexion and extension, through the changes in contraction. It didn't change because of the direction of pull, still pulling the same. Contraction. Flexion, extension. Flexion, extension. So the function of the tricep is extension and flexion. I had both, and it was responsible for both. So how? What's the magic? What am I missing? That. The tricep, which is part of the elbow extensor group, influences variations in motion elbow flexion, elbow extension through differences in contraction, concentric and eccentric. Guys, if you can get this sentence down, the rest of your career in kinesiology is going to be a heck of a lot clearer. It's just the light is going to go off. Ah. Muscles, through their groups, influence motion through contraction. Now, again, why do I emphasize groups? Because I've mentioned it in the previous video, but it's so important. Because if all you ever do is say bicep, tricep, hams, glutes, quads, you leave out other important muscles. The bicep isn't even the prime mover of the elbow. So if you never talk about the brachialis, you never talk about the brachioradialis, you never talk about the teres major, you never talk about these muscles, it's like cocoa. When you die 2 deaths, when they forget about you, you no longer exist. In addition, understanding muscles in groups is going to help us when we talk about stretching. What I mean by that is showing how things that can only pull get lengthened when they have motion in the opposite direction of their pull. To make that super simple, if I have muscles that pull in the direction of horizontal adduction, and I understand that I have a group of muscle, I have as many muscle groups as I have joint motions, and I understand that I have muscles that pull this way, by understanding that I have a group of muscles that pull in the direction of horizontal adduction, we can easily talk about, well, I would stretch those muscles that pull this way by horizontally abducting my shoulder. Horizontal abduction stretches those of which pull in the direction of horizontal adduction. It makes that concept so much easier. So much easier. Trust me. So, short, sweet, to the point. I guess sweet is debatable, but I'm trying. Know this. Know it. Know it. I'm sending good, positive, osmotic, understanding vibes to you. If you have any questions, let me know. Until next time.